Question, sir.
I want it to be like...
Write a pass. I'll let you go. Yeah. Like in your agenda, or just on a piece of paper.
You know what I mean?
Oh, I might have it. But anyway, just on a piece of paper, and then do that, okay? All right, guys. Here we go. All right, we're going to get started here on...
Don't tell me you're doing more than...
Yeah. That's how we learn things.
So many
How have
Can we
you
do, like,
done math in the past?
We just do worksheets and learn.
Just worksheets.
Yeah.
Well, okay. So we're talking about introduction to transformations today.
May I ask what you're doing on graph paper?
Sorry?
Can
What?
I write it on my notebook?
Well, we're going to be doing some graphing and stuff. So you're going to want to have the graph. We're going to do our notes on graph paper because we're going to be doing
Alright, so
we're going to be doing transformations in the coordinate plane.
How does this have anything to do with geometry?
I don't like to, I want to write the letters.
You want to write the letters inside the box? I hear you. And you can. I mean, like, you can write it that small if you want to. Or you want to write each letter in each box?
Yeah.
Oh, I hear. I'm sorry about that. Well,
I know.
shh. Okay, here we go. So, yes, I can hear you. This is... Oh, man, I'm already getting...
You should never write your child's book.
There you go. All right, so what is a transformation? Okay, so a transformation, it is a function that changes the position, shape, or size of a figure. Okay, so a transformation is a function that changes the position, shape, or size of a figure. Now, you guys did transformations last year in Algebra 1 Common Core, right? You would take functions and then shift them left, or shift them right, or shift them up, or shift them down. You guys remember doing that? Yeah, okay, exactly. And those were transformations. Believe it or not, those were transformations. You were doing a little bit of geometry there with your function transformations. Okay, we're going to do some more transformations. We're going to talk more about those kind of transformations, I guess, here today. Okay, so anyway, when we do a transformation, we start out with an original, okay, kind of shape. Okay, the original. Sometimes the original is also called the pre-image. And that is annoying to me that we call it that, and I'll explain that in a little bit here. Okay? So sometimes we call it the original image, or it's also sometimes called the pre-image. Okay? And then, so we can call that, like, just as a quick example, if there's a single point, we call that single point like point P, right? So we name that thing like we would normally name a point, like P. Okay? We take that original image, the pre-image, or the original, or the pre-image, that, point P, or it's made of a bunch of different points or whatever, and then we transform it. Okay? And there's some transformation, and we'll normally be given the transformation. Sometimes we'll have to come up with a transformation. Okay, so it undergoes a transformation, and then it becomes the image. Okay, and that point's name is no longer point P. It's now called point P, and they put a little apostrophe above it, and that's called P prime. P prime. Okay, and I'll put that here in print. I'll put that in quotation marks. P prime. Because that means that it's been transformed. All right? So like Optimus Prime, he's a transformer, right? Okay? So a transformed point is P prime. That point's name prime. Okay? If we were to transform it again, so if we were to transform P prime, what would we call that? P prime prime. Okay? So each transformation adds a prime to the name. So the original or pre-image is P. transformed is P prime, transformed again would be P prime, prime, and then transformed a third time would be P prime, 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 and so on and so forth. Okay, and then it gets kind of like crazy after that. But we don't really do more than 2. P prime, 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 prime. That's right. Okay, we'll say like P triple prime, okay, or P quadruple prime.
Prime 3.
So there are other notations and stuff like that, because yeah, it would be kind of crazy to have like 10 primes out in a row. So anyway, okay.
The apostrophe means prime. The apostrophe.
Sorry.
The apostrophe means prime.
Yeah, the apostrophe means prime in this case, in geometry. Okay, when we see that with transformations. Okay, now there are 3 main ones you guys learned about in like elementary school, have known since elementary school, right? So we have the slide, we have the flip, and you have the turn. Okay, slide, flip, and turn. We're not going to really use those names anymore. Okay, we're in high school. We're like official, geometers. We're official people that study geometry. And so we're going to use, instead of slide, we're going to call that, does anyone know like the official mathematical term for slide?
Slide.
It's translation. Translation. So that's the word we want to use there, translation. Okay, so a slide is a translation. Okay, instead of a flip, what are we going to call that? Reflection. Okay, so we're going to talk about translation, reflection, and turn is a rotation. You got it.
Why can't we just say slide,
Slide, flip, and turn? Because we want to learn our new vocabulary. We had our vocabulary back in elementary school. Now we have our new vocabulary we want to use here. Okay. There's one other type of transformation that we're going to like name. Okay. So there are many other transformations besides these 3. Okay. These 3 are kind of special, and we'll see kind of why that is in a little bit here. Maybe not today. But there's one other transformation that we have a name for, and that's called a dilation. Okay. Now, dilation is a word, okay, that you maybe have heard before. For example, have you ever been to the eye doctor and gotten your pupils dilated? What happens to your pupils when they dilate? Well, so actually I hear bigger and smaller, and guess what? They're both correct. Okay, so in a dilation, a shape can either get bigger or get smaller, but it still maintains the same shape, right? So your pupils don't suddenly become squares. They're still circles, right? And so when you dilate pupils, either they get bigger or smaller depending on, what's going on and stuff like that. But
When
yeah.
your eyes fall off, they get small.
What's that? They get too small?
They said that they fall off.
I think Derek, you know what? I don't know. Maybe Derek knows something. I've never seen it happen before. Maybe Derek has. I'm sure that if they fall off, you can just put them back on and like with a little bit of tape and it'll be fine. Good as new. So.
That's fine.
No, Jason, I'm kidding. I don't think that's an actual thing. I think that's an actual thing. All right. Let's graph here. Okay. So we're going to perform the indicated transformation and identify it. So I'm going to use the words ID for that. Okay, so that's going to be our directions here. We're going to perform the indicated transformation and ID it. Okay, so we need to start with the shape first of all. So let's draw. Okay. We're going to draw some coordinate axes. 0, -1.
Does it say ID?
Yeah, ID. We're going to identify it. I just wrote ID instead of identify for short.
Wait, so we flipping this one?
Well, we'll find out what happens here. That's part of the part of the question is we're going to identify what transformation is occurring here. What kind of transformation? So go from -5 to 5, if you would please, both in the X direction and in the Y direction.
Can you just give us like a minute to do that?
Yeah, sure. And then I'll plot the points too, so that we can have those as well.
I'm getting real stressed out.
All right. I'm sorry if I'm going too fast. I don't want math to be any more stressful than it already is.
We colored that one day outside. My husband was like running out of lead.
The coloring. We're drawing pictures right now. All right, so here you go. Shh. All right, let's get copying here, guys. Make sure we get this down. Third word, rotation. Perform the indicated transformation.
What point is that 3? Is that point 3?
Is that point 3?
Is that point?
Yeah, it's at 3. Yes, it's on 3. Yes. Yes. Okay, and then the indicated transformation. Here's the transformation. Okay. Okay, so there's the indicated transformation. Absolutely. Okay. So again, I'll give you guys an opportunity here to kind of get finished with the graphing and things. Okay. So some of you might be able to look at this, okay, and I know I haven't taught you how to do this, but some of you might be able to look at this and already kind of know what you need to do. It looks like we're taking a point xy, and then this is indicating a transformation, and then what are we supposed to do with that point xy? What is this indicating we should do?
You should go left 4 and down 3.
So x, and then this is minus 4. So what should we do with our original? What should we do with our original x coordinate?
Reflecting.
Or actually not reflection,
Why reflect?
because if it's on that side, then it goes to that side.
I say translation.
So we're taking our x coordinate and we're subtracting 4 from our x coordinate. I'm not worried too much right now about what kind of transformation it is. I'm sorry, what I'm worried about is just like, what is this thing telling us to do? Every x coordinate, we're supposed to take the x coordinate and do what? Subtract 4, right? And every y coordinate, we're supposed to take that y coordinate for that point and then do what? Subtract 3. So, when we transform a shape, what points on the shape do we transform?
The actual point.
So, yeah, the vertices, okay? And if we just transform the vertices, then we can kind of fill in the rest of the points, right, by just connecting the dots. Truly, though, when we do a transformation, we are transforming every point, okay? But like, Jason kind of indicated here, that would be a lot, right? It would be too many to transform every single one of these points along these sides. So instead, we just transform the vertices like he suggested, okay? This xy is supposed to represent the pre-image points, and then these points over here will represent the image points. Okay, so let's take a couple seconds and just list off these pre-image points. So I'm going to list off point A. Okay, and point A's coordinates. Okay, point A's coordinates are what? What are point A's coordinates?
4 and
0, 4.
0, 4, yes.
Okay, and B's coordinates are what? 3, 0, and then C's coordinates 0, 0, right? Okay, and then all of those are going to undergo a transformation. Okay, so let's see here. I'm going to take A's coordinate. In fact, if you guys want, this might not be a bad idea, is to actually show the math here. So we're going to say A prime now. It's going to be 0 minus 4. I'm going to show the actual work first, and then, yeah, you're right, though. It is going to be negative 4. But
So why is it 0 minus 4?
because we take our x coordinate, which is 0, and then we're going to subtract the 4. Okay, we take our y coordinate, which is 4, and we're going to subtract 3. So I plugged those in, kind of. Okay, 0 minus 4, 4 minus 3. I see I plugged those in. I mean, you could just do the mental math, or there is a simpler way to do it. Yes, we'll talk about that. We'll talk about that. We'll talk about that. And Ryan kind of hinted at it earlier. Yes. Okay, and so then if we simplify this point, A prime is 0 minus 4. That's negative 4. 4 minus 3. That's 1. Okay, so that's our new point, A prime. Oh, that's off this. Sorry. There it is. Okay, and then we'll do the same thing for point B. B prime will be 3 take away 4. Y is going to be 0 take away the 3. Okay? And so then that becomes B prime is -1, comma, -3. Okay? And lastly, C. Well, C prime will then be 0 minus 4 and 0 take away 3. Okay, and so that will be then C prime, which is -4, comma, -3. Yeah, it's a lot, but it's also, you know, pretty simple arithmetic. Okay? So now to plot this, I'm going to plot A prime, B prime, and C prime. So A prime has coordinates -4, 1. So there's A prime. -4, 1. Okay? B prime has coordinates -1, -3. For B prime?
0 minus 3.
Yeah, 0 take away 3. And then C, which was 0, 0, C prime is now -4, -3. And then we can connect the dots. Okay, like so. All right.
See, I like this. This is easy.
You like it? Good.
This is a flip.
Jason. I know you meant that. So slide, or in our terms, what is that? A translation. Now,
So, what's a flip? Does it legitimately flip? A flip is a
well, Jason, I guess you're just going to have to wait and see what it looks like, because we're going to do one here in a little bit, okay? But, let me ask you guys a question. So translation is the correct, you know, name for this. Can anyone be more specific about how it's being translated?
Oh, it's going down
left,
four.
four.
No, no, left four.
Left 4,
And then down to the 3.
left 4,
And then
down 3. Okay, yeah, we can look. Here, to go from A to A prime, we have to go left. 1, 2, 3, 4, down. 1, 2, 3. To go from B to B prime, left. 1, 2, 3, 4, down. 1, 2, 3. And C to C prime, left. 1, 2, 3, 4, down. 1, 2, 3. Okay?
So look at your beginning parentheses.
Right. So, Ikeva, so what do you mean we can look at our beginning parentheses? How is that indicated to us already?
Well, that's how.
We take the point x, y, and what do we do with our x coordinate? We subtract 4. The x coordinate is in charge of going which direction? Left or right. So if we subtract 4 from the x, it means we're going to go left 4. If I wanted to go right 4, I would do what with the x? If I want to go, instead of doing a left 4 transformation, how can I write a right 4 transformation? X plus 4, exactly right. Okay. If I wanted, so, and here the y minus 3, that's indicating going down 3 units from my original y coordinate, so that means we're shifting this whole thing down 3. Okay. If I wanted to go up 3 units, I would write y plus 3. Okay. So you can kind of see here, is it necessary to write out all this work when really all we have to do is just go left 4 and down 3? And the answer is no. Yeah, you don't really need to show all this work here. I just want to show you that it does work when you do the work, because there will be transformations where you're like, I'm not really sure what this is going to look like, and you can always resort back to doing this.
we've done this before, right?
You have? I don't know.
Yeah.
Okay. All right. Well, that's good. So then we'll press on then here. Okay. So next one. Okay. So again, let's draw here. I'm not going to take as much time to slow down a bit. Yes. I'm sorry. Where are you? Okay. So we're just going to draw some coordinates here. Don't worry about numbering these. Okay? If you don't number, I'm just going to assume you're counting by ones. Okay? So we'll just not number these. That means we'll assume we're counting by ones here. Okay? So don't number them. That just takes extra time. Okay?
There's 5 of that, right?
Sorry?
There were 5 on each side.
Yeah, I did about 5 on each side. Yes. Okay, but again, you don't actually need to number these.
Alright,
Okay.
Where's the thing? How do we start?
Okay, great, right, so what's our coordinates? Okay, so we're going to do S, which has coordinate, and I'll go ahead and write these over here. So our pre-image,
Wait, do we always have to do that thing, pre-image?
again, just for our notes, yes.
Okay.
So we're going to have R coordinates -4, 3. S will have coordinates -1, 3. And T will have coordinates -4, 1. Zoom in a little bit, yeah.
So so where's your image though?
We're gonna get to that. We'll get to that. We'll get to that. Nope. And we're gonna take those points, and then this is how we're going to transform them. Okay, so we're gonna take those coordinates, and that's how we're gonna transform them. And I'm gonna take. Let's see. I'm gonna draw the originals. Let's see. -1, 2, 3, 4. So there's R, -1, 3, and then T. So again, we have another triangle we're going to transform here. Okay. All right. Now, does this transformation that I wrote up here, XY, arrow, -XY. Does this look like it will be a translation?
No, I think it was.
Probably not, right? Because we're not adding or subtracting anything to our X's or Y's. So it's probably not going to be a translation. So it's probably going to be one of the other ones I indicated. Okay? So we'll see. Yeah, right.
Actually,
For that, wouldn't you pretty much do like a parentheses with like a negative outside? You know,
Yep.
Like, you like put the number in the parentheses with its negative and put that in your outside.
Exactly. So R prime, okay, is going to become -4, comma 3. The Y's stay the same. See the Y's, they stay the same, but the X's, it becomes the opposite of that. So I put a -4.
What is a negative?
Well, we'll talk about that.
Wouldn't it be positive?
What's it?
Yeah.
S prime is -1, comma 3. And then T prime is -4, comma 1.
Wait, what? Oh, you just.
I'm plugging the X's in, and there's a negative in front of it. So that's why it's like negative.
It'll be positive 4.
So exactly right, guys. So yes, R prime, when we simplify it, then is going to be +4, 3. S prime will be +1, 3. And T prime will be +4, 1.
Wait, so this will be a flip, right?
We'll see. Okay, let's plot the points. Plot your points. Okay, once you got those down, go ahead and plot them. So S prime is 1, 3. Make sure you label them too with S prime.
This one is a flip, right?
Looks like it, right?
Yeah.
It kind of looks like, yeah.
No, because if you fold your paper in the middle, it goes back into.
So this is very clearly not. We don't want to call it a flip, though, Jason. What do we want to call it? A reflection.
You know how you can check your answer if you fold your paper?
Exactly right. You can fold your paper to get it to match up. Okay. What? So here's again though. Shh. When you talk about a reflection, you're normally reflecting over something, reflecting over a line. Okay. In general, we reflect over lines. Okay. At least in this class, you can reflect over other stuff, but it makes it more tricky. But anyway, reflecting over a line. What is our line of reflection here, or where kind of like is our mirror, so to speak? Where would it be along what? Zaria?
I don't know how to say it, like that.
Okay, it goes over. That's right. What's the line it's going over, though, Haley? The y-axis. It's going over to the y-axis. The reflection over the y-axis. Yes, Haley?
if it's like across, like a vertical kind of thing, that's still a reflection.
If it's a...
Like, instead
instead of like right next to it, it's across from it.
What do you mean by that, I guess?
In the third coordinate.
The-
Right, the third.
Like here?
Still below it.
This one?
Yeah.
Oh, sorry, this one. Shh, listen up, please. Yep.
Like that.
If it's down in here.
Yeah.
And then, oh, if it reflects from here down to here?
No.
The original
The
shape
prime-
is here.
Okay, wait, I messed this up. The prime, say like the prime was flipped like vertically. Is that
So from here down to here is what you're saying.
No.
If the
Like-
prime was flipped vertically.
Okay, so if PRS, the
Yes,
original one,
yes.
was on the opposite side,
Down here.
no, like right next to it. The
Can you
next-
draw me a picture of it? So, like, draw a picture of it on your paper there somewhere, and I'll
like
take a look.
this, if this was flipped in this coordinate.
Oh, it could be down there. Yeah, it could be
So
reflected down
that's
there.
the-
You can, you see, yeah, you can reflect over like diagonal lines too. Is that what you're trying to ask?
Yeah.
Yes, yes. So yes, we can reflect over diagonal lines. We won't go too crazy with that. There's only really one diagonal line we're going to reflect over. That's the line y equals x. It's a very easy reflection to do. All the other reflections over like other diagonal lines are hard to do. Okay, we won't worry about those. But these ones, yes. Okay, so there's our identified transformation. Okay, continuing on here. I'm sorry. Yes. Am I? Yeah. So, Shardes, are you keeping up okay? Or
That's fine, but.
you're good? All right. But I mean, did you understand everything so far, Jaden? Okay.
Turn the brakes on.
Now pump the brakes, Mr. Wood. All right. All right. Excuse me. Okay. Let's do another one here. Okay. So we're going to do the same thing. We'll get another transformation going here. Okay. Here we go. Okay. Okay, so let's try this one. And I'm just going to write the transformation here. So I'm going to take xy, and we're going to go to negative y, x. So you can see what's happening here. xy, what happens to the coordinates? The coordinates switch, and then the y becomes the opposite number. Okay, good. I hope so. So I'm going to give us the points here. A, 1, 2.
But you messed up.
Do you have to draw a picture?
B. Do you have to draw a picture?
If you already have the points and everything, like, you have to draw it.
So, no, but it's to identify the transformation. It's really helpful to see that picture,
There's
though.
no way to tell, like, from the pen.
You can kind of tell. For example, Jaden, if you look back at the previous, like for example, at the translation, when it's like x minus 4, y plus 3, you can look at that and say, it's going to be a translation, it's going to be a slide, left 4, up 3, however we want to say it, okay? Rotations, reflections, those are a little bit harder to see, but again, you might get like a feel for them as we go, okay? You might get a feel for them as we go. But if not, Jaden, just keep in mind, you always can fall back on graphing, okay? So, I messed up. I did not mess up. This is what I want to do, okay? So, let's see how these now transform. So A prime, and I should zoom in maybe a little bit here. Okay. So if A was 1, 2, A prime, we have to flip that order.
So it'll be -2, 1.
Negative 2, right, because the y coordinate, it was positive 2, becomes negative 2, and then 1 is the x coordinate still there. Okay, B prime. What will B prime become? Negative 2, 4, good.
I bet that's already 2, then it becomes a positive, right?
So, right, exactly. So for C prime, our y coordinate's negative 2, but it's going to be a negative 2, so it becomes positive 2, and then 3. That's right. Very good. Good job, guys. That's right. Good job. Okay, so now let's graph it, because I have no idea what kind of transformation this is based off of that. Okay, so again, I'm just going to sketch some axes here. Hopefully I made them big enough. If not, that's okay. We can always like readjust or whatnot. But I think that should be big enough.
How come it's always in the shape of a triangle?
Just because triangles are kind of, I mean, mostly for speed of you know our completion. Because if I made us do like 5 points, we have to do 5 calculations instead of just 3 calculations. So. And a triangle, you know, it's a shape. It's a solid, not a solid shape, but it's like it's a shape that, you know, it's filled in and stuff like that. If we only did 2 points, it wouldn't be really a shape. It'd be a segment. I don't know. There's more interesting stuff that happens with triangles. So anyway, let's plot A. So A is 1, 2. B is 1, 2, 3, 4, 2. And C is 3, negative 2.
Never draw like.
So there's C. Okay. Now let's take this and let's plot our new points. So let's see here, negative 2, 1. There's A prime. B is negative 2, 1, 2, 3, 4. B prime. And then C prime is 1, 2, 1, 2, 3. Yes, good eyes. Okay, and I think I heard Jason, you said that too, right? This is A. So guys, what kind of transformation is this?
It's
Rotate. Just rotation, actually. Yes, sorry.
It goes like over.
So yeah, so what are we rotating around? Because when you rotate, that means you have a center of rotation. What's our center of rotation here? What point is the center of rotation?
No, C.
It's 0, 0. The center of rotation is our origin right here. Okay. And yeah, for us, it's always going to have a center of rotation of 0, 0 because it makes it very tricky when it's not that. Okay, so.
So can you like write a definition on like our notes, because like I know I get how to do all of this. The only thing that will probably mess me up in the long run is I can't tell the difference between a translation and lecture.
So Ikeda, that's a great, and that's a great feeling, and that's what we're going to do as we move along here. So today we're just doing like an overview of all the transformations, and then tomorrow we're going to focus specifically on one, and then the following day specifically on one, and hammer those down more specifically. That's right. Right now we're just doing an overview, Okay, but that's an excellent feeling. Okay, one more I want to show you here. Okay, one more, last one. So you're like, wait a minute, Mr. Wimar, we've done translation, we've done rotation, we've done reflection, reflection, rotation. So what's the last one that we have to do still?
Is it possible to do 1 over 3?
Make it smaller, bigger.
So you guys hear Krishna's question. Listen real quick, please. So Krishna, what was your question again?
Is it possible to like do all 3 like?
Yes, but we're going to focus, so that's called a composition of transformations, I think, okay, so we're going to do that later, though. Once we kind of hammered out the basic 3, okay, as much as we can, we're going to then look at doing a composition, or doing more than one transformation, okay, because again, it gets more complicated, more calculations, and it's harder to see sometimes. Okay, so there's our, there's our rule. Okay, there's our rule. Go ahead and give us our points. So let's see here. Do I have those? Yes. Okay, we'll do JKL.
Jason,
Jaden?
Okay, JKL. Oh, yeah. Okay, I'll talk about that. JKL. So, right, we're multiplying our coordinate by 2, so, interesting. So we have a prediction that it's going to get bigger by 2. Is that what you said, Derek?
Yeah.
Bigger by 2. Okay, let's see. Okay, so J prime, K prime, L prime. Okay. So let's see here, what will be the new coordinate for J prime? New coordinates.
It'll be 3.
So 1, the x-coordinate of 1 becomes 2 times 1,
Oh, so it'll be
2.
2.
It's a weird.
Oh.
And then 1 for the y. Still, the y stays the same. The k prime's x-coordinate,
So then that will be
2 times 2, 4, and the y-coordinate stays the same. And then L prime's new x-coordinate, negative 2 times 2, so negative 4. And the y-coordinate, negative 2. Yes?
Will they ever get us any harder than that?
Harder as far as like the math that's
Like,
required?
will it
Or?
be like complications?
There'll be, I think, at most 2 things you have to do. So this is just 1. All these have been 1. So there will be, yes, a little bit more difficult with 2 things. But You can take them in steps, though, too, James. You can do, like, one thing and then do it again for another thing, so. Anyway. All right, let's graph this real quick and see what the heck is going on here.
Mr. Whitmire is a mascot. No, I was
It's beautiful, Jason, thank you.
the geometry.
Is this the last thing we're doing?
This is it. Yep, we're done after this one.
Mr. Whit. Geometry.
All right, so again with the triangles, I know, again. Don't worry, we'll do more than just triangles, but just for what we're doing right now, I want to do triangles. Okay? And so let's plot the new one. So J prime is now 2, 1. K prime is now 1, 2, 3, 4, negative 1.
Mr. Whit,
Question?
are we ever gonna have, like, they've all been triangles, or like,
There will be other shapes, yes, Jason. Okay, there's my transformation. All right, so is this a translation? No. Is it a rotation?
It's a size increase.
So we might be tempted to call this a dilation. This is actually not a dilation either, because dilations, well, how would you maybe describe what is happening here? From the blue to the red, what's happening?
getting expanded.
Getting
By
bigger.
2.
It's getting.
But is everything in it getting multiplied by 2?
No, the X.
Yes, no, only
Yeah, look, the from J to J prime, it does not go up at all. It stays the same height. K to K prime also, it stays the same height. L to L prime. So we can imagine kind of taking our triangle and stretching it, right? We stretch the triangle out, okay, horizontally. If you were to take it and kind of stretch it out, it's multiplying the triangle's width by 2, basically,
Yeah, but
okay?
If you were to stretch it out,
Yep.
it doesn't look like it would look like that because the triangle, the little triangle shape isn't in the big one.
Well, see, that's what I'm saying, though. Because we're not stretching it the same, we're not stretching the same vertically as we are horizontally, so this is not a dilation. A dilation involves both the same stretch vertical as horizontal.
And
So that's
we'll
why
write
it's...
that in the definition.
So we're going to worry about the dilations later. So this has no name. Okay, it's just a transformation, but no name. Just transformation, no name. Okay, so I'll get you guys your assignment here.